again, thank you very much for for inviting me. And today I want to still keep in the migration and integration team, but this time is not the time of Composite, it's the time for Kotlin Multiplatform. And in this presentation, I want to show you what you need to do to introduce Kotlin Multiplatform in an existing project. And all the stuff that I'm going to say are based on a true story. And it's the story of introducing KMP on my previous company. But before moving on, I quickly introduce myself. I'm Marco, I work at Tier. I'm based in Berlin, but I'm from Venice. And these are my internet handles if you want to stalk me in the web. All right, let's start immediately. And yeah, Kotlin Multiplatform, and Kotlin Multiplatform that is very hype nowadays, but I can tell you that the hype it's real, and it's real because Kotlin Multiplatform is not like the other cross-platform solution because is not about sharing everything, but it's about sharing only some part of the code. So with Kotlin Multiplatform, you can share the code that is not UI code, and that's because it's difficult to find a common solution that that makes happy every platform, because every platform has different situation, has different architecture, and something like that. So to simplify things, we can share only code that is not platform code and does not touch the UI layer. There are different possibilities and different platforms that are supported. We can support the JVM in general, so more like Java or Java project, so desktop project or Android. We can also support the web world, so the browser, so a web app, or even the web backend with Node.js. And finally, with the native part, we can cover the Apple world with iOS, macOS, watchOS, tvOS, and also other platform, other desktop platform like Linux and Windows. But today we are going to focus more on the mobile side. So we are covering the Android target and the iOS target. But of course, you can mix things up. And for example, only with this mobile target, you can, for example, add a JVM target to be able to share stuff with the backend as well. All right, so it's this talk is about existing project, but in order to understand better what's it's necessary for existing project, we have also to cover what we have to do with new project. With the new project, it's of course more easier because you're starting from a blank canvas basically. And so what you can do for a mobile project is to use the Android Studio plugin that you can install on Android Studio, and basically it lets you start and create all the boilerplate for a Kotlin Multiplatform mobile application, basically with a couple of clicks. So you can select in the classic Android Studio wizard, you can choose the KMM application, and then automatically the project is created. And this project has everything in its folder. So basically, it's a monorepo where you can find the Android application, the iOS application, and also the shared module with all the Kotlin Multiplatform code. So everything in one place. How it works? Well, on Android, this is pretty straightforward because the shared part is a Gradle module. So it is imported in the Android application like every other module, like the module that, for example, you are using in your modularized project. So what you have to do, or no, you don't have to do it because the plugin already does it for you. But what it does, it's adding, it's including the Gradle project inside the setting.gradle.kts file, and then add the dependency inside the build.gradle file of the application. So pretty basic. On iOS, instead, it's difficult because, of course, it's a completely different planet. Gradle can talk with the Xcode pipeline. So in order to ship the shared code, we need to build a framework that is that is the binary, the container of the binary code for Apple platform. So basically the equivalent of the jar for the JVM world. So in this case, we need to create a framework, and in order to do that, there are two different ways. We can create and build a framework with a Gradle task that we are going to see in a moment, or we can use the CocoaPods dependency manager, and that is a different way. It always creates a framework, but it's more useful if, for example, you are planning to add other dependency on your iOS application using the CocoaPod dependency manager. Again, you can choose it between the two ways inside the Android Studio wizard. So for the regular framework, there is the framework is created automatically when you start a build from Xcode. And the framework is created with this very long Gradle task that is embed and sign Apple framework for Xcode. And this task is automatically bundled inside the Kotlin Multiplatform Gradle plugin. So it's not visible for us. And this task is available starting from Kotlin 1.5.20. Before that, there was a manual task named pack for Xcode that was automatically added in your build.gradle file. So probably you have seen it around if you have tried KMP before. As I was saying before, this task is called automatically by Xcode when a new build is necessary, basically. So the architecture of the required architecture and the bug and the type of framework, so the bug or release, are automatically chosen by this framework. So if we are running in the emulator, automatically the framework is built for the emulator, and if we are running in a device, is automatically built for a device. And if we are packing everything for the App Store, then the task is going to choose the appropriate configuration. For the CocoaPod integration is more or less the same. Oh, sorry about that. There is a glitch on the slide, but yeah, don't worry. For the CocoaPods integration, a framework is automatically generated, and then Xcode knows how to pick that framework because we have defined it. We have told him to do it in the pod file. So basically, it's importing our framework like a usual iOS library. And in this pod file, probably you are going to have different other libraries if you are using some libraries for the iOS world. All right, that was quickly how things work for new project. Now we have some basic to understand what's going on for existing project. So for a new project, we have seen that we have this structure, so a monorepo with everything inside it. But for existing project, it's not usual that you have a monorepo. It could be, but it's not for granted. So, and plus maybe you don't have so much time, and so you can't spend your time that you have allocated to move into a monorepo, because there could be also business constraint or many different problems. But fortunately, we in software development, we can still ship our code in a different way. So we can make a library and use that library to ship our Kotlin Multiplatform shared code. Of course, so for shipping that library, we need to start from something. And in order to do that, we can start from something that is something little, something that is not so big to start with. And that's because you are in the middle of a migration. You need to understand if this migration works for you, if it's the right solution for you. So you can't, for example, spend your entire allocated time for migrating the entire network layer. It's not worth it, because if at the end you find that it's not a good solution for you, you have wasted lots of useful time. So where to start in reality? Where there are like lots of questions and answers in software engineering. It depends, and but there are some places that are more likely to be used for as a starting point. For example, we can start from code that is boring to write multiple times, because if a piece of code is boring to write, then it's 100% error prone, because we get bored and we get distracted and we make an error, basically. So if we write this code once, then we have only once possibility to make an error, not twice or multiple. Another starting point could be, again, some code or feature that centralize the source of truth, because again, if there is only one source of truth, then there is only a single point of failure. But the most important thing to take in mind is that we start from a feature or from a piece of code that can be gradually extracted, for the reason that I was telling before, because you have to start little, and then if it works for you, keeping up with the migration. All right, so what are these places in reality? Again, of course, it depends, but for example, you can start from DTOs. And for example, in my past company, we started from DTOs because we thought that it would be a good starting point to minimize error and the contract between the backend and the mobile clients. So that starting point worked for us. But of course, you can start from many other places. For example, you can start to share your common models, again, because you define in one place what are the contracts for the UI, for example, or for your business logic. Or you can start from utility methods that every project have. So in this case, you define once for all them. Or you can start from, for example, analytics code that is boring to write. I I, for example, hate writing analytics code because, yeah, it's just analytics. And of course, you can start from whatever other place you are particular to your project. Okay. Now that we have decided where to start, we have to start. So we are shipping a library. So we have to create a library, and the place to go for me is, for example, is IntelliJ and not Android Studio, because Android Studio, the Android Studio plugin lets you create an application, not a library. So with IntelliJ wizard is much simple to do that. And in this case, we are not shipping or better, we are not exposing a Gradle plugin on Android, but we are shipping the binary. So we need to create an Android library. So we will ship an AAR, and for iOS instead, we are still shipping a framework, because that's the only way to go. So in this case, since we are in different repository, then we need to publish these libraries in the cloud or somewhere else, your internal network, USB key. No, don't do it, please. For Android, for example, you can use Maven. And for example, we use it because we were already having a Maven infrastructure set up for other libraries. So for this Kotlin Multiplatform library, everything was set it up. But maybe in your situation, your company, your project, you can use something else. And for the iOS framework, instead we used Cocopod, because we were already using it, and so everything was, and it made more sense to use it. But of course, here you can use, for example, the Swift Package Manager or Cartridge or whatever as publishing thing. Then the actual mobile project will pull the dependency and use internally in the project. So to summarize, we have 3 different repositories: one for Android, one for iOS, and one for the Kotlin Multiplatform library. Okay, so now that we have clarified the architecture, let's publish for real. And we start from Android because guess what? It's simpler than iOS. And before moving on, every snippet, every piece of the code that I'm going to show you in the slide is available on GitHub in a sample project that I've made. And this sample project basically is a simplification of the architecture and all the stuff that I've made in my past company project. So it's a simplification, but it's based on a true project, let's say. All right. So for publishing in the Maven repository, it's very, very simple because we can use the Maven Publish plugin, and so all the stuff that we have to do is define the plugin, define the group of the library and the version number, and then specify, of course, the Maven repository where we want to publish all our artifacts. After that, everything we have to do is running the publish Gradle task, or you can also run the publish to Maven local Gradle task if you want to publish the artifacts in the Maven repository of your local machine. So maybe you don't want to have cloud-based meme library, or you are just trying stuff if it works before reaching the cloud. After that, all the stuff that you have to do is adding the implementation on your build.gradle file, like you do for every other different library. And that's it. From now on, your Kotlin Multiplatform code is visible in your Android application, and you can start using it. All right, now time for iOS and time for some sweat, because yeah, it was more difficult. And the problem is that we can't use the same structure of existing project, of a new project, sorry, because as I told you before, the m&design Apple framework for Xcode task and the CocoaPods integration computes at runtime the architecture that we want and also the configuration that we want. So, but for in this case, if we are shipping a library, we don't know before which architecture will the iOS team use, or which configuration. So we need to ship everything. And in order to do that, we can use the XC framework from Apple. That is a new type of framework that contains different architectures. So the architecture for the simulator. So x64 if you're using an Intel-based Mac, or ARM64 if you're using an M1 machine, and also the architecture for the device that is still ARM64. But beside that, on plus of that, you can also ship different target of platforms. So you in the same package, you can ship stuff for iOS, macOS, tvOS, and watchOS. And this has been introduced during WWDC 2019, if I remember correctly. And before that, it was difficult because the way to do it was using a FAT framework that was kind of similar. But with the FAT framework, you cannot ship iOS and macOS together, for example. So you had to have different FAT framework for iOS, macOS, watchOS, etc. So it's kind of boring if you are developing Kotlin multi-platform application with many different targets. All right, there is an official support for XC framework on Kotlin, but this support has arrived only from Kotlin 1.5.30. And before that, it was a bit difficult. Let's say you had to do some manual work. You had to first build the framework manually, then pack it together with the Xcode build CLI tool. And since I'm lazy, I created a Gradle task, actually two Gradle tasks, one for debug, one for reveal, to automate everything. But I'm not going into that because, yeah, I hope that everyone use a recent version of Kotlin. But if you are interested about it, I wrote it on my blog, so give it a look if you are still using Kotlin prior to 1.5.30. All right, so now what you have to do is in new Kotlin version, you have to use XC framework. You have to, first of all, import it in the build.gradle file. Then inside the Kotlin block, it is necessary to create a new instance of the XC framework, pass it optionally a name for library. And then in every source set that we are using, we have to add the XC framework. We have to have, the framework into the XC framework. So we have to do it for every platform. So if I'm supporting, for example, here macOS, we will have a macOS block, and inside it, we have to add it, the framework we have to basically copy and paste this thing. And that for every target that we wanna cover. After adding that and syncing your project, 3 new Gradle tasks will appear. And so these tasks are for building the debug and release version of the XC framework, or for build it both at the same time. If you run this task, the XC framework will be created and placed inside the build folder of your project. So at this point, you are ready to take this framework and ship it outside. But yeah, how to do it? Well, as I told you before, I choose to go with CocoaPod, with a CocoaPod repository. So what you can do is create a new Git project and use it as a CocoaPod repository. And in order to do that, you have to create a pod spec file that is a Ruby file with some configuration, and that you have to write to let Xcode know how to pull the dependency. I'm not going into the details, but if you're interested, there is a very well-made tutorial in the CocoaPod repository website. And one thing that I want to point out is that, of course, you can use also a private repository, because maybe you don't want to open source your stuff. All right. Now at this point, you can, when you have published everything, you can import the framework into your project. And to do that, I follow 2 strategies. I publish the developer version on the develop branch of the repository, and then instead the stable version are published into the main branch with a tag. So in this way, I can use the developer release quickly without using tags, and so we can iterate faster and publish new version until a stable version is reached. All right, so in order to publish something, we have to build it. We have to move it into our Gradle, into our repository. We have to commit, publish, update the version, all boring stuff. And since I'm lazy, guess what? I created a Gradle task for that. So I created a Gradle task for publishing a developer release. And this Gradle task basically makes a checkout into the develop branch. Then it builds the framework. It copies it from the build folder inside the Git folder that I'm using for publishing it. Then it updates automatically the version inside the pod spec file, and then finally it publishes everything on the develop branch with a standard commit message. So I can hit the command and everything is get published automatically. For the release version, I've done the same thing. Of course, in this case, it's gonna check out into the main branch, build the release framework, move it again from the correct folder, and then tag the version with the version name that is created into the build.gradle file. And yeah, finally we have our infrastructure to publish a new framework with not so much, with a bit effort to to create it, but not so much effort when everything is ready, because all we have to do is just hit a Gradle task. All right. Something else to take in mind when starting to integrate a new Kotlin Multiplatform thing is concurrency, because right now concurrency, the memory model of Kotlin Native is different from the JVM for construction reason, but things are changing, and in fact on next spring Kotlin Multiplatform will reach beta, and there will be a new memory model that it's more easier than that one. But for the timing, you have to keep in mind that if you are using one thread, there are no problems. So you can use mutable objects. But then, if there are many threads involved, you can't share mutable objects between different threads. So in order to do that, you have to make them immutable. And so probably you're gonna meet this beautiful exception when you forget to make an object immutable. And in order to make it, you don't have to. In order to do that, it's not enough to say that a variable is a val instead of var, but you have to explicitly make the object immutable. And in order to do that, there is a function that you can call, and this function is freeze. That basically frees the object, and after that you can share it with different threads. So you have to remember it, but I think that it's not so difficult, let's say, and impossible if you start architecturing your business logic with immutability in mind. That it is always a good practice. But if you are doing that, then and then you forgot to freeze the object and the exception is raised, all you have to do is just freeze the object and everything. It's gonna work. So yeah, it requires attention, but it's not, let's say, an impossible thing. As I told you, things are changing, and there is already a new memory manager that you can use. It's in the developer preview, so you can start trying it, but it's not ready for production yet. So if you want to try it, and maybe report bugs if you find any, but in spring, it will be stable, this new memory manager, and it's gonna be you don't have to change your code basically, and the freeze operation gonna do nothing, and so you can update without even noticing. All right, so now we have reached the end of our journey into Kotlin Multiplatform, and let's try to bring up some conclusion. So in order to start introducing Kotlin Multiplatform, there are some difficulties, let's say, that I faced. The first one was how to organize the project without a monorepo. In fact, before there wasn't so much sample and example online. So in order to understand that, I need with separate project and repository, it was possible. It required me a bit of time. And then, of course, the other difficult stuff was to understand how to effectively and properly distribute the iOS framework without too much trouble. But yeah, after some lot of sweat, let's say, I think that I reached a satisfying solution. All this stuff moved me into thinking something about the experience. And so what I want to say is that if you are starting with Kotlin Multiplatform, I suggest you to start little and then go bigger. And that's because you have to validate, first of all, your entire infrastructure, if you can share and how you can share everything between your repository. And so you have to do some, let's call it DevOps work at the beginning to understand if it's okay. So if you decide to migrate, let's say, the entire network layer, then and then you have also a lot of time to validate the process, then I think that it's not worth it if at the end it's not working. So if you start from a little class, a little model, a little DTOs, a little function, whatever you want, and then you validate that everything is okay, it's working, it's worth it, then you can start going bigger and share more features and share everything as we want. And in fact, my past company, we did exactly that. After seeing that sharing the DTOs was really good and was a good solution for us, we decided to even share the persistence layer of our application with SQLite and then write SQL once for once. And yeah, it was a nice experience, but it was it was easier because everything was already set it up, and the only thing that I had to do was create a new project and start with that library because the infrastructure was already there. So that's it from my side. These are some resources that I used for this talk and that you can use to, if you're interested in know a bit more. But don't worry, I'm gonna share the slide on my Twitter account. So make sure you follow me to get it. And yeah, that's it. Thank you very much for staying with me, and I hope that you enjoyed it. And if you have any kind of question, I'm here to answer that.
Yeah, thanks for your presentation. And we do have a lot of questions. Any problem? So let's go into those. Sorry, can you hear me?
Yes.
Okay, so let's go to the first question. It's from Hamza Elmi. What are the things that you couldn't share between frameworks? Could you share use cases having Flow implementation, for example, or data sources using retrofit Cater?
Okay, so you can share use case with Flow, but you can't, let's say, use Flow directly into Swift because it's not a thing in there. But you can write a wrapper in your in the iOS target that basically transform the flow into into like a callback, and you can even map the flow into I don't remember the name, but it's the correspondence of the flow that you can find in the combined framework. So you can have a mapping between them, and so in this way you can have something like a flow in your Swift code. And you can also share data sources, not with retrofit because it's not a multi-platform library, but you can do it with Cater. And yes, if you're using suspending coroutines for the network call on Android, it will work out of the box. On iOS, you can or create your own callback or starting from Kotlin 1.4 point something. I don't remember if it was 4.0 or 4 point something, but doesn't matter. You can call directly coroutines from Swift, and a callback is automatically generated that will be triggered when there is new data.
Okay. Next question. So how difficult was it to find out what to write in order to make the publish Gradle task work?
It was a bit difficult, let's say, because at the beginning I was not, let's say, I didn't add too much experience with the Gradle because, except for basic configuration and basic Gradle infrastructure, basic Gradle sharing infrastructure between different modules, I didn't do anything special. But yeah, it was a bit difficult to understand what to do. I look into different into online, into different resources that I found out, into samples, and also I dig a bit inside the Kotlin Multiplatform Gradle plugin. Fortunately, with IntelliJ navigation, it was it's easier to navigate into the source and to find what to do. But fortunately, with in next Kotlin release, there will be improvement on the Gradle infrastructure, even for sharing frameworks. So let's hope that in the future it's more, it will be more easy to share everything.
Yeah, it's always fun to write Gradle tasks.
Yeah, and actually, I go into the rabbit hole, and so from this unbundled task, I ended up creating a Gradle plugin. So yeah, I went into the rabbit hole.
Yeah. So next question. It's from Sri Harsha Chilakapati. I hope I won't mess the pronunciation up. How does the memory model changes affect when you are using Kotlin code from Swift?
So basically, what is changing is that you don't have to call it to freeze the object when you are sharing from different thread, and so you will be able also to use coroutines into background thread, and it will be the surface level changes are this, but so pretty simple. Basically, your code is still gonna work because you don't have the memory border will be used, even though you still have the freeze call in your code. You can delete it, of course, but you don't have to if you don't want. And so there will be a seamless and a migration without breaking changes, let's say. Is the surface line. There are a lot of different changes underneath, but I don't wanna. I fall into that rabbit hole as well, but it's I know. Let's keep it simple for the question.
Yeah, thank you. So next question from AJ Kukani. Is KMM completely secure and can be used in large-scale mobile apps? It is still in alpha stage?
Yes, it's in alpha stage, but it's secure to use. What they mean by alpha is that some stuff can change, and there could be some breaking change, and let's say the tooling is not stable, so you have to deal with changes. You have to fix things. You have to deal, for example, with the memory model that is different and all this stuff. So if you if you know what are you doing. So, and by that I mean that if you understand that could be changes, could be changing the tooling, something to adapt, it's you can use it because it's not let's say broken and stable on the app level. So yeah, you can use it, and there are big companies that are still using it, for example Square, and many other.
Cool. So just a quick for your information, if you like some questions in the Q&A section, do vote them up, because we will be going in the order of upvotes. But as it is right now, I think we will have time for all the questions. I just sort of FYI, it's also true for all the talks in this in today's meetup. So next question, again from Sri. Does KMM support plugins like Flutter and React Native does?
I don't know what you mean for plugins, but maybe you're meaning if there are libraries that provides.
I had that understanding as well. I think he means libraries.
Yeah, but there are, for example, I know there is a library for Bluetooth. So yeah, you can. There are plugins, and if you need to call something native in your code, you can do it, because there is the expect actual mechanism. So you can define in the common module a function that is expected, and then you can provide the actual implementation on the native part. And that's kind of, let's say, the concept is similar for what you do with plugins on Flutter and React Native, but on Flutter and React Native, the communication is made with a JSON basically, and here it's completely different, because at the end you will have the compiler will find the native implementation that you have defined, and all it's native. There is no passing around of JSON, so it's more and more quicker and native and performant.
Cool. Okay. Next one is a fun one from the Galor Mini. How do you get your iOS team to agree?
That's a number one question. For my situation, was a strange situation, because we were a startup with a little team. For a certain amount of time, I was only me doing both Android and iOS. That's why I thought about doing Kotlin Multiplatform, so I can avoid some duplicate code. Then another iOS developer enjoyed, and it was on board and happy about it. The kind of strange approach that we found and we followed was that I was mostly maintaining the underneath part of the application, so up to the data layers and something like that. That was written in Kotlin Multiplatform, and it was doing the upper part of the application, so the user-facing one, so the front end and the back end. Let's call it. But this is, I understand that this is a different and completely strange situation. But in general, when there is a big iOS team, you have to find not an agreement. It's ugly to say, but you have to be on the entire mobile engineering team has to be on board of that, and you can agree on trying Kotlin Multiplatform. You can sell it for the fact that you can write something that minimizes errors. You can be up to speed. The iOS team can, in fact, also fix some issue on Android side, because they are fixing a common part. And so the entire engineering team will benefit from it, because we can swap people on working on something that will work on both platforms. And I think that this kind of thing, that to be able to support each other and fix and correct and understand everything, it's a very good thing and a good solution, let's say, for the future.
Okay. So the last question, it looks like, from Gabor. Have you considered using Badoo's reactive, of course with a K, for multi-threading in KMM?
Yes, but I hate RX, so that was the reason. Basically, I don't. I prefer so much coroutines than RX, and so yeah, that was the main reason, basically. But yeah, it's, if you're more into RX, it's a very good library. I know people using production, for example, Karim. Karim, it's using it from many time, and they are satisfied with that. So yeah, depends on, let's say that it depends on your, again, it depends, and it depends of your, what you like.
Yeah, of course. Okay. Thank you. I think that was all of the questions. And thanks again for the beautiful presentation and a lot of information.